Hello everyone, this is my call for high trust computing. A couple days ago, Neuralink gave their update on the progress that they've made with their Neuralink device. And the Neuralink device is just a brain-machine interface or brain-computer interface. And what is that? That looks something roughly like this. You have your brain, you have some sort of device that connects to the brain and can talk with the brain, and then you have your computer, your phone, your internet that connects to that brain-machine device. And the idea behind Neuralink is that it can actually have information go both ways. So you can actually read information from the brain, and then you can write information back into the brain, or at least that's the goal. That's the idea. Now, one thing to keep in mind is that a lot of the things that they talked about the other day are very far away, right? So being able to download memories and upload memories to your brain, or have telepathy or things like that, those things are actually very far in the future. There's a whole lot of research and engineering that has to be done in order to solve these problems and make those things actually possible in a real-life device. But we should be talking about the consequences of those things right now, because we don't want to wait until the problems pop up and then to try to solve them once we have problems everywhere. So one of the things that I want to talk about today is not the brain-machine interface itself, but actually what the brain-machine interface connects to, the whole rest of the world, the whole rest of the environment, the computer, the phone, and everything else that you would connect the Neuralink or brain-machine interface device to. And the thing I'm very concerned about today is actually the safety and security of the environment that you're connecting to. The problem that we have today is actually the architecture of our computers. And so we'll get to that in a second. Let's run a scenario. So let's say that you can actually store, let's say sometime in the future, you can actually store your memories, your thoughts, your feelings onto an external device, onto just a flash drive or a hard drive. Imagine that those files can get tampered with, right? So someone tampers with those files, and now you have false memories that are stored on this external device. Right? So that would look something like this. You have your external device, which is connected to your computer, your phone, or whatever, and the files that you store from your brain get tampered with somehow. Well, the thing that they talked about the other day is that the Neuralink device is relatively safe. They're working on encryption mechanisms, and the Neuralink device itself actually provides a nice, it cordons itself off from the rest of the environment. So it's not possible for someone to directly send signals into your brain from some other computer. They have to go through the Neuralink device, and that's awesome. That's very good. But the problem is that there will be signals and files that you store that have to come into the device and then will be sent to your brain, right? So that means that if someone is able to compromise your keys, or if they compromise your computer or your phone itself at, say, the silicon level, then they can tamper with those devices. The encryption keys that you have become completely useless if the very silicon itself is compromised. And that would allow Neuralink to actually send signals or false memories directly into your brain. And so that means that it could cause you to have, suicidal thoughts, or have false memories, false beliefs, right? There's all sorts of ways that you could think about manipulating someone's brain, and that would be very, very bad. Now, the problem here is that we don't want these files to be tampered with, right? We want to have your information only really be manipulable by you. And in order to do that, you're definitely going to need encryption, and you're going to need to be able to sign your memories with the encryption keys. But the ultimate problem is not the Neuralink device. It's actually the rest of the world, what everything else your Neuralink device or brain-machine interface connects to. So your computer, your phone, all of that. And the problem is that the architectures that we have for these computing systems, the x64 architecture, the ARM architecture, are fundamentally flawed. They are so complex that they cannot actually really be audited. Additionally, companies have paid to have special registers put into these computer chips. So the computer chip manufacturers have been paid by governments and other companies to put special registers in there. There's even processors inside your processor, right? And a lot of these things are completely undocumented, and security researchers, it's up to them to find these things and try to figure out what they do. But what this means is that at the lowest level, at the silicon level, your computers are compromised. And so what we need is a new architecture, a very, very simple architecture that is safe, secure, and that can be audited by security researchers. There should be nothing that is not disclosed, right? So things like RISC-V are great, but I'm talking about an even beyond that. We need to have an entire system, not just an instruction set architecture. I'm talking about a complete system. And I call these kinds of systems high trust computing systems, right? And because it allows a person to know pretty much for sure that the data computations that occur on that system are not compromised by the outside world. And if we're going to have this, we need to do this research now. We cannot wait until we already connect our brains up to these devices, right? Because then we'll be stuck. We need to create this kind of high trust computing environment now, and we need to be doing this research now before things like Neuralink and other brain-machine interfaces become ubiquitous. And this is something that I cannot reinforce this enough, that we must be doing this now. That is pretty much all I have to say about this, other than high trust computing, I believe, is the future. As people connect more of their brains to the computing environment, and even without any of these brain-machine interfaces, more and more of our lives are being tied to computers. We depend on computers for pretty much everything, for our microwaves, our cars, our banking systems, and these systems right now are fundamentally insecure. And so the high trust computing environment, I believe, is an enormous market. It's worth probably today at least hundreds of billions of dollars, and whoever does this research and whoever develops these technologies early on is going to dominate the market. So I just wanted to put a call out there that we need to be doing this, and that's all I have to say about that.